All right, welcome back everyone to AJC and the Web Devs. How's everyone doing? Someone has some sirens in the background.
Oh, yeah, living in the
Okay.
city,
No, it's all good. So you are our guest. So we have I only know you right now by your Twitter handle, which is Spacey. You want to introduce yourself to our guest? Are you a Twitter anon, or do people know your identity?
No, I'm not a Twitter anon. People know my identity. I'm sort of like semi anon PFP. I don't know. I change it up all the time. So I'm not particularly. I've had the same handle for a long time, and I've had my name on there, and I switched to Spacey, and then back and forth because that's what I use on like Discord, and I'm more on Discord than anywhere else. So
Where does Spacey come from? What does Spacey mean?
nothing. It's like an inside joke. So
Okay. No, I get it. I've been recently posting all these pictures of parakeets and porcupines. This is in joke between me and my wife. It's like these characters we've created. We're creating all these images with us. So it's,
yeah.
I totally get it. It's fun. So but you want
Yeah,
to introduce
it's
yourself
hard
to
to keep
your
the same like Twitter personality forever. I think I'm sort of
yeah.
pushing ones to like change it up all the time.
No, I
So
feel that. Yeah.
that's why I don't get
So what's your
tattoos either.
so what's your background? Like what companies do you work for? How do you get into software development? Like who are you as a dev?
Always been into software. Love software. I founded some companies before. And then ended up joining, and one of them was like did pretty well. It like won TechCrunch 50 and stuff back in 2010. After which you ended up joining LinkedIn in the Bay Area, and I was with LinkedIn till around 2016. So I basically worked on ads engineering there but I worked on all kinds of things. I worked on like the API platform. I helped build like the share button that LinkedIn had. I worked on like moving the whole front end from like this old JSP, whatever mess to like Ember.
That's right. LinkedIn built very heavily on Ember, the front end
Yes.
framework.
I mean, honestly, I'm not
Something a
like
lot
an
of people
Ember
don't
person
know.
specifically. I'm mostly
Yeah.
like I'm personally more of a React guy, but like there was an
Sure.
issue with
Yeah.
the Ember licensing, React licensing. So I think
I
that's
remember
why
that. Yeah.
LinkedIn wanted to put its flag with Ember and kind of own that community, sort of own that framework and be able to influence it, and worked out well for them. So
That's
yeah,
super
so I've done
interesting.
a bunch of stuff. Then
And then how'd you get into the LLM AI space?
yes, I'm sort of coming to that. Then I kind of moved
Yeah.
to working back on like trying to experiment with my own startups, and at that point I was building this idea called 42 papers, 42 from Douglas Adams.
Sure.
And papers, because like I was reading a lot of research papers, and the idea was like it's the answer to life, universe, and everything in those papers. And it was just like, and I this was back in like 2017ish, where I saw like this rise of the archive, and and it was just like it was a fire hose back then as well. So I wanted to be able to like distill the knowledge from there and just kind of
This
like
is it right
surface
here,
that.
right? 42 papers on Twitter.
It is, but it's kind of discontinued. I think, yeah,
Yeah.
that's probably
Just so people can see it if they
Yeah.
want to get the history.
It's not an active project right now because it was
Yeah.
heavily dependent on Twitter APIs. I had a whole pipeline built to kind of take the knowledge from Twitter and who is kind of sharing what, blah blah blah, and then be able to like go down to archive and extract those papers and get the value from there. And there was no way I could do that. Like I had my vision was like here, and what I could do was like here because there was no LLMs really. I
Sure.
had this
Yeah.
idea where we'll crowdsource all this and kind of do that way, but it just wasn't like working out well. And I started stumbling into like BERT and some of the early models then. So I started using them for like classification and entity extraction, and then soon when I
Can we
started,
pause?
sure.
So I just want to say, can we talk a little bit about BERT actually? Because I saw you mentioned this somewhere, like a tweet or something, and I think this is really so. I'm a huge history nerd, and I love history of tech. And I think BERT was super important now in a way that people at the time would have no idea how
Yes.
important that tech was going to become. So explain what BERT is.
So BERT was technically the first LLM, okay, or LM. Maybe it wasn't large. I don't know. It's by today's standards, it's not large, but back then it was huge. So before that, most of like ML, they didn't even call it AI, they called it ML, right? Was based on you needed to do all this like artisanal work. You had to like find features and you had to figure out these like trees, abstract syntax trees around all your grammar, and then you had to like it was just a lot of manual work. And BERT was and you had these models that were specifically like designed the architecture and all bunch of stuff around like doing a specific task. But again, I could be wrong, but like BERT was the first time I saw a model that was quite generalized. It was just this one model. It could do several things. It could do classification. It could do named entity extraction. It could do like several things, and you didn't have to like do any like special work to use that model. It was sort of like the earliest signs of what we see now, right? And and BERT is actually also a transformer model. It uses something now most of transformers are what they call decoder only, but BERT was a bidirectional transformer. So if you look at the original transformer paper, in that paper, it's like got a second little transformer thing at the side that's feeding in to the main decoder stack, and they call it cross attention back then, and that doesn't like that's not how majority of the big transformers models are built now. They're just a decoder only stack. But anyway, so BERT was that, and a lot of the techniques on like training and like masking words, and then like getting the transformer to like guess that word as a way of, to pre-train. All of that was like sort of invented, I think, during the BERT for BERT essentially. And it was out on Hugging Face. It was a model we could use. There were several like fine tunes of it. Was easy to tune. It was like honestly, I don't remember. Maybe 500 million parameters or something. I don't know the exact size. And there were several models out there by Allen AI that had like taken Allen AI is this
Which is from
institute out here in
Microsoft.
Seattle. Yes,
Yeah.
I'm not sure if it is Microsoft, but they do a lot of NLP work. And back then they had all these like models focused on archive. I started using those, and honestly, first time I got it to summarize text, and I saw it like print out these things. There were obviously mistakes and all that, but it was very, very, very good. And I was like, wait, what just happened? Like, honestly, that was like I would say my like moment of like conversion or whatever you want to call it. Like
I love
and
that because I use these things today so much for
yeah,
summarization, taking huge chunks of text, parsing it down, giving it
yes.
something smaller, both for myself and for content I create, and just so many things.
Yes. And it was like, and when I'd never like I've spent my whole life building all kinds of complex computer systems, in ads. It's a lot of like low latency work and all like, and I had never seen like, and obviously computers felt magical to me when I was younger, and I kind of had got that feeling again when I saw this thing kind of like convert this huge like, I wouldn't say the whole, obviously not the whole archive thing, but a huge chunk of it into a great description of what the paper was about. And and obviously when you work on distributed systems, or you work on one of these like these whatever, like you spend your career in computers, you tend to know how most things work, right? If someone told me to write a kernel, I could I figure that out. Someone told me to write like a
Sure.
firewall, or some
Who
kind of
can't write a
distributed
kernel?
system, I would, I would have all. But like this, I was like,
I
wait,
could not
what
write a
is this? How
kernel.
does this work? What's going on in there, and that was fascinating. And so it kind of put me back into like the learning mode, which I love the most. Like and so that's sort of where the journey began. And I think I kind of ended up with those kind of models and the Hugging Face ecosystem for a long time, until I think like GPT-2 started like showing up outside of OpenAI. um, and yeah, that's the history of where I kind of started this.
That's awesome. And some marks for people. BERT was 2018 and GPT-2 is 2019 roughly when those were coming out. And then it took, 4 for three more years for that to turn into ChatGPT, which then all of a sudden this thing seemingly shows up out of nowhere, blows everyone's minds, revolutionizes the way all of society and culture sees AI, and has put us on this whole journey since then. And yeah, it all came back to these language models. That's
And
super cool.
just to kind of interrupt you there, like this BERT and stuff is not by any means like old school or shouldn't be used. These are really powerful models even today.
Mhm.
And I still use them for classification and certain specialized tasks. Hugging Face has a great ecosystem around them. They call it sentence transformers. And they have a small library called SetFit where you can like tune them. So you can use like 20 examples and get a really, really high quality, fast as hell, dirt cheap classifier. And you could use this for large amounts. Like I have like spiders to gather data for certain things, and I end up using SetFit and like BERT models to classify pages and stuff at scale. Trying to use like a big LLM beyond that is just overkill and too expensive, too slow. So there is huge value in these models today. So
let me share this so we can see that was not the right thing. It was
now that I see this thing, I really feel like I need to revive it. It was the API changes to Twitter that really brought that down.
I want to share SetFit, this thing. You sent this, Monarch, in the chat. So this is the sentence transformers that you're just talking about. Yeah, no, this is super cool. We should talk about
cutting edge. You could still use this today, and you should use this today for like if you're trying to build like complex pipelines and stuff.
Yeah. But we should talk about LLM Client. This is what you're working on now. So what is LLM Client?
So so when I started getting into bigger models and started writing code around like GPT and stuff, obviously OpenAI, that's the one I started working with, and I realized there was a lot. What was interesting about these things is that they had this API that was relatively the same. This is the first time we're seeing like several companies like have the same API for like one task. It's kind of unusual. So I said, you know what? The first thing we need to do is we need to abstract over this. So because I don't know what I need to use here, and I want to try several things. I had that experience that sometimes there are different models for different things.
Wait, what do you mean by the same API? And what's the
Like
API?
essentially a text
why
prompt.
is that important?
Well, I'm talking about LLM Client in sense. Initially, all of these guys have just a text input. That's it, right? Every LLM, no matter how big it is, it has just one text input and has one text output. So essentially, now you're dealing with these like services that have the same API. So now you can abstract over this, and you can basically talk to any one of these LLMs internally. So I'm talking again, what I'm talking about is how LLM Client started. It's evolved into what it is. But on day one, the idea was whether I want to use OpenAI, I want to use something else, I want to use like a local one. I want a singular abstraction over all of these. And so I started out abstracting out an API that would work with all the LLMs. And that's what we kind of achieved with all the cool features like streaming and function calling and all of that. Additionally, I also wanted that same interface on top of vector DBs, which were also another critical component of like building with LLMs. So once I kind of had those pieces in place, I started to look into prompting, and I realized that I didn't like enjoy it because it was there was no way to like reason about it. It was like, oh, do this, don't do this, no, please don't do this. I'll give you my firstborn if you do this. $50 for that, and like it just and every time and so I found myself not using avoiding using LLMs where I just should be able to just throw an LLM at it, because like it was a lot of work. It's like I have to maintain these blobs of text everywhere in my code, and there's no way to reason about it either. Like, what if I change this? What if I don't give it $50? What if I offer it $20? Is this like better? I mean, like I don't know. Maybe I should give it $1,000. I don't like that. That's not engineering. That's just I don't know, like pros.
Divination.
Yeah, exactly. So I was always unhappy with that layer of it. I tried several things. I tried templating systems and There was like someone had built like a React like JSP style layer to like build these prompts, and until I kind of stumbled into the DSP paper. That's the demonstrate, search, predict paper. I mean, the name is kind of like DSP, demonstrate, search. What the hell is this, right? I mean, but the essential idea of this paper is that, and this is what I took away. There's a lot of really valuable stuff in, and the author is, hats off to him to actually put so much in a single paper, because the trend now is to try to get multiple papers out of one thing. And I can dig into what are the different things, but what really stood out to me was the fact that, and I knew this, but essentially I had not internalized it enough, that LLMs are basically pattern matching engines. So you can, to work with them, what you need is high quality examples. And this is a learning I had even from the days of like BERT and SetFit. This whole era of like models that are instruct tuned, where you can be like, hey, I'll sacrifice a little, chicken to help, help you give me this text or whatever, right? That didn't exist. So when these models came on, they were not RLHF, or they weren't instruct tuned like Robert and stuff BERT and stuff back then. I'm sorry.
Hold on.
They're pattern matching. You have to give them patterns.
What is instruct tuned? Just for people.
So what happens is that when these models are built, first they're pre-trained, where you just take a whole bunch of tokens or text and you throw it at the model, and you just give it like sentences and remove like mask words and say, can you predict this? And you just like train it without any real real goals. You just like give it as much tokens as you want, and then you get these like models. They call them, people call them base. There's no real term for them. Let's call them base models or raw models, right?
Foundation models.
Try to talk to them in English, they're not going to be able to talk to you, right? I mean, they're not able to understand these like English. I mean, they do, but they're not designed. You cannot like ask them for stuff. That's not how they work.
They don't embody personhood the way the things you've gotten used to do.
Well, I mean, they're not like their weights are not tuned to work with instructions. Essentially, they are tuned to work with examples. So you're supposed to give them patterns, and they will complete the patterns. So if you give it, Bravo, Delta, Charlie, then they will give you India, blah blah blah. Like they'll basically try to complete patterns. Like if you give it a you say whatever. Like if you say Mary had a, then they would say little lamb. You couldn't say like what did Mary have, and it would not be able to answer and say little lamb.
Right. It's like completing the text. Yes. That's why you would set it up to, you could give it text to say there's two characters,
yes,
you and it, and then you're talking to it, and then it will be able to abstract that out and understand it's a conversation where it's supposed to respond to you.
Yes, they would just complete things. I mean, then they would just go on until where they feel they should stop. Sometimes they'll just have half a page of like predictions, next token predictions. That's it. And the way you get them to do what you want is you stuff examples into the prompt. So if you put in a lot of like poems in there and like and then you say examples, and then you say Mary had a, then they would complete it. Because if you just said Mary had a, it might not say had a lamb. It might come back and say I had like I don't know, had a wrench and was working in the garage and whatever, right? So like that's how it's like you put enough stuff in the prompt, and they'll help its attention mechanism like find the right probabilities, the words of the right probabilities for what you want by examples. And then we came to this era where honestly, I don't know if OpenAI started this, but essentially these models started getting instruct tuned. So if you see the earlier models and you see models out there, they'll be instruct. So they're like a base raw model taken, and now they've been given tasks. They've been said, here, this is a special format. Here I'm going to put in the task message. Here I'm going to put what's expected reply and some other like parameters, and then you'd basically see if it could like give you that result you want. So this is essentially like you're tuning it for tasks. So these models are like, they've given them a lot of text summarization or question answering, or there's a huge variety of tasks. I know we tend to think that they do anything, but they don't. They just basically do what they're trained on, GPT-3 or 4 or whatever, and they've been trained on these tasks that, they know we're going to ask for one of these things.
Awesome. So do you want to demo some stuff for LLM Client so people can get a sense of like what it does?
Sure, but yeah, so maybe I could just kind of complete my thought on DSP
Yeah,
before
go
that.
for it.
Yeah.
Awesome.
So,
Sure, yeah.
so essentially, and then obviously after that is RLHF, which is the reinforcement learning through human feedback stuff. That is the final piece that it's like the polishing. Once you're done with the whole cabinet making, they polish it with this feedback just to make it really palatable to humans. So it would like say what you think it should say and be polite and all of that stuff. So we've taken effort to make it talk to humans, right? I mean, like if we were trying to get two LLMs to talk to each other, or this reinforcement learning to human feedback might not even be needed. I don't know. I don't know enough, but I'm just guessing it's like the ability to make it palatable. But it's the core of the models where you give it examples and it then does something is still there. So and that's really powerful, and DSP leverages that. So yes, you do prompt it for a task. You say, can you summarize this or whatever? But then you give it examples of the inputs and outputs expected within that prompt. And then what that causes it to do is give you, great high quality response and be more consistent. So if you're building like a production workflow, then you're going to get the same high quality, like it's more deterministic. Again, not 100%, but it's way more than without doing any of that. Additionally, DSP is the idea behind DSP is you're building programs. It's not just one prompt. The one prompt might do summarization. The other one might extract some info from there. The third one might do something else to it, like break it into bullet points and then complete certain fill in some more information. So it's like this tree of work, right? And these examples need to flow through this tree as well. So when you need to be able to set examples for all of those different prompts through the whole chain. And you want like a programmatic way to test the stuff. So you want to be able to give some basic prompts, some examples, then run the thing against an evaluation engine where you can see how it performs. And then all the input outputs of that evaluation chain, you want to save it, the best ones, and use them as examples again. So it's like a loop to improve the quality of the examples. And and DSP is that, and that's how the framework works. The framework basically initially allows you to create this tree of workflow, this pipeline of LLM tasks, and then be able to set examples through this whole pipeline easily. And if you really want to take it ahead, it has the concept of tuning, where you can have an evaluation data set, and then you can test how well your pipeline works against it, and the data flowing through it is captured as traces, and the best ones can then be used as examples again, improving your workflow. So this is equal to tuning a model, but tuning it in context. So the whole concept of in-context learning is basically a model can be tuned within the context of a model. This was not something you could do with older models. You could only, in-context learning is an emergent ability that has come when the models have become really big.
Yes, I love this. This is something I've been talking about a lot actually recently. And so how recently would you say this has happened?
I think GPT-3, it's kind of people started seeing it, and it's and then it's just basically there, and we don't know when the models get even bigger what other abilities might have there. But emergent, but basically the idea behind tuning, yes, I mean it's valuable when you are and some of the ideas around DSP are about like collecting these high quality traces and either using them as in context for a faster loop or training a smaller model with this information. So it's sort of like capturing the data set that you're going to need to train a smaller model to be effective at this complex workflow you've devised, right? The idea around building with LLMs is it's not about throwing the biggest model at it. It's about like being efficient, fast, deterministic. Yes, you could throw the biggest model at it, but then you're like overkill. And And it's useful only to generate those high quality traces. But once you have that, you should be able to use that with smaller models. So essentially, that's sort of the loop here, right? So you could use, like, if you use Gemini Pro, then you could use like Gemini Flash or GPT 3.5, but you've generated your traces using GPT-4. So you can build these. And additionally, as a second thing that really attracted me to DSP, it's the prompt signatures. So the idea behind prompt signatures is it's an easy way to define your prompt as set of inputs and set of outputs. And the LLM client framework has taken it further, where you can even have types on them. So if you say, I need this to be a string array, then we'll enforce that with error correction and everything and make sure you get a string array. If you need a number, a Boolean, that'll be enforced. You don't have to struggle with like JSON and all that stuff, right? Which
yeah, I was sharing this earlier. This is you have a visual here for this. Monarch, did you have a question though?
I wanted to dig deeper into traces, but if Spacey, are you gonna demo? Because if you're gonna demo, then I think the traces are just gonna be like evident what the traces are. Otherwise, I wanted to ask you about traces.
We can go any direction you guys want to go at this point.
I can show some code later, but we can just talk.
Yeah, so you said traces. So my understanding is that traces are like logs of inputs and outputs, right? So
yes.
So why is that important, and how does that fit into the examples that you feed into the model in the beginning, and then how do you improve those models using the traces? Could you maybe talk about that?
So okay, when you're trying to improve a model, right, you want to tune it. That's essentially like that's the common knowledge right now, is let's tune this to improve the performance of it on a certain task. So how do you capture that?
Tune, you mean like actually do like a machine learning algorithm using PyTorch or whatever? That's what you mean by tune?
No. So the tuning is either like let's just start with OpenAI, right? OpenAI has a tuning API where you can take GPT 3.5, you can give it a bunch of data, and you can say, I want to tune this. So it basically, however it does it in the backend. But in the open source world, there are several ways to tune. People use something called LoRa, low rank adaptation. It is like these. They don't change the weights of the main model, but they add these little like tiny models, these little matrices all over the place inside the model, and then tune those. And then essentially the model becomes better at the task it's tuned for. And there's a lot of research around the fact that, you can't introduce new knowledge in through tuning, but you can sort of fine tune its use case. Like it becomes better at its use case. So tuning, there's a whole world of tuning. There is a library called Unsloth. A lot of people use that with Collab to tune all kinds of models like Mixtral and Llama 3 and
what
stuff.
Was it? Unsloth?
Unsloth.
So you're basically
like sloth, yeah.
Yes.
So you're basically freezing the original weights, but then there's a small set of weights that you're still tuning on top of the original weights.
So there are multiple ways. There's a lot of research here, but essentially most tunings do not touch the original weights because those are just too much. If you're trying to tune those kind of models, it'll never work for you. You just will not have the hardware or the time to be able to tune. So in lieu of that, people came up with other mechanisms where like they added these like adapters on top of the model and tuned those adapters, and then all the outputs of the model are basically sort of like multiplied with those adapters, and you get and then basically you've essentially tuned the model without like changing the weights of the main model. So in today's day and age, most of these models are frozen, the big models. You don't really mess with them, and you just tune stuff around it on top. And but that's like when you actually want to like tune it using LoRa and some of these techniques where you're like changing the weights of the model. But there's another tuning where they call it in-context tuning, where you can just generally put a lot of information into the context, and that'll help the model be like if you put a lot of examples
when you say context, you mean the prompt, right?
The prompt, exactly.
Right.
So if you put a lot of examples into the prompt, you're basically doing the same thing. Yes, I mean, it's a little more expensive because now you're consuming it. But in most of these prompts, if you look at the pricing, for example, the inputs are far cheaper than the outputs. And in addition to that, going ahead, there's going to be all kinds of caching tech coming up. Like Gemini is going to have prompt caching, where it would take the parts of the prompt that are not changing, like the examples and stuff, and sort of like tokenize them. And again, I obviously don't know how they do this, but they're going to hold on to that and somehow not charge you for it, or charge you very little for it.
Gotcha. So
Yeah.
moving this towards LLM Client. So we have the traces, and the traces are like a log of all the input-output pairs that are actually being generated. So if your users are using that,
for each signature through the whole tree of tasks that you're trying to do, and they're all cataloged properly. And then they're also tested against an evaluation thing that you have written, like a function or some data. So the best ones are kept, and the ones that are like, if you're asking it for like capitals, right? I mean, and then it says, you say, what is the capital of, I don't know, whatever, India, and it says, DC, Washington, DC, then you don't want to keep that trace, essentially.
Right.
So that's up to you how you can have another LLM evaluate the outputs, and then signal say keep this one, don't keep this one. That's entirely up to you. The point of using these giant models is to get high quality traces to then productionize with smaller models.
Gotcha. So you take those examples, and the goal is to just put it
but
into
we're all lazy
BERT.
and we just like instruct big models and go with it, and which is fine. But the idea is that if you're capturing traces over time, if you're trying to build like solid production workflows, you can bring down costs and improve performance and all of that using these learning loops.
Gotcha.
So,
gotcha.
And the framework basically helps you with that, but the framework helps you with several other things that you just need out of the box. Like you obviously need ability to figure out what formats, like you want to assert certain types on the output fields. I'm working on this feature where it will be able to, like, because I don't depend on JSON or something, I can start processing the output in a streaming fashion way before it's complete. So if you're expecting a lot of output, but it's not matching the assertions, like the types or something, I can then like fail fast.
Interesting.
And essentially, stuff like that. So there's all these capabilities that are constantly added in, which is why the value, like people say you don't need a framework. I mean, sure, but then you don't need a compiler and just write assembly or whatever, right? Like I think there's
I'm a fan of
the
frameworks personally. I like frameworks.
So, but I do like light frameworks. For example, LLM Client has no dependencies. So it has like 0 dependencies. It doesn't depend on any of the clients. Like it can support like 10 of the top LLMs, and it's all coded from scratch. And there's a single, there's a single input interface. There's a single like API, and that maps to all the APIs for all the different things internally. And I don't depend on their client libraries or any of that stuff, right? So it gives the engine gives people working on client complete control over everything. So I can automatically detect if something has streaming capabilities or function calling capabilities and behave differently and stuff like that. It's sort of like vertically integrated. It's like the Apple philosophy where you own everything, so you can build better products.
That makes sense.
And so all these pieces come together, like the function signature stuff, right? I mean, I would have loved for it to just be functions. But I haven't figured out a way in JavaScript and TypeScript to just like take functions in real time, like parse their structure out. So function signatures work great, and and it's basically kind of made working with LLMs more fun for me, and that's sort of like a goal of mine. I want to just be able to throw an LLM anywhere, and a signature, and with LLM Client, you literally throw it in one line. Just do new, generate the signature, boom, and there's a forward function that you can basically use, passing it input outputs, and you're good to go. So in fact, some of the workflows I've built personally for my stuff have like several LLMs involved. Like I use like Gemini for like extracting out data from big files, like certain sections, and then pass that on to like GPT-4, where the context length isn't that much. So I want to be sure, and I want to like already pre-process it with other LLMs before I give it to GPT-4 to make it do like the complex work. I think a lot of people are, again, it's new, right? So I don't blame anyone, and the knowledge around this is fuzzy, but I think a lot of people trust the LLM a little too much. So they would take something like GPT-4 and they'd be like, hey, can you do this, that, and this, and then return it as JSON, and then, also blah, blah. Like you're not going to get any sort of consistency because that's not how it's trained. This model has been trained to do everything and be God. It's trained for tasks. So you want to get it to do specific tasks.
Yeah, it might be slower if you layer it into separate prompts, but that's how we build software.
Yes,
anyway.
you want to split it into separate prompts, and that's beautiful because sometimes you can have things running in parallel. You can have it serially. You can, you can walk that tree, well, as as in how you need it, and you're going to get far better, lower error rates and performance in general because you want solid results, usually. So.
Yeah, if you look at it like a program and you look at the LLM as just a runtime environment, like it's just code, then you start. This is my experience. I don't know about you or anybody else, but when I started looking at LLMs as just this is going to process something and it's just code, now I can actually apply solid principles and dry principles. I can apply object-oriented patterns now to LLMs, which is something that I don't see a lot of people doing. A lot of people are saying, oh yeah, let's use an agent framework, which are fine, LangChain, whatever, they're fine. But I don't see a lot of people saying, how do you layer your prompts into services and data access? And nobody's really talking about that. The most I've gotten is you can build a DAG out of it. But nobody's really talking about, oh yeah, okay, we can actually split these up into object-oriented components and mix and match. And
No, and you're completely right there. I want my LLM usage to feel just like code. Like if I'm writing a bunch of code, I don't want these giant things in their middle, like these multi-line text blobs, and I want it to be another line of code, and that's kind of what I'm going with. Like for example, I do have support for agents in LLM Client, and they also accept signatures. But what really is an agent? People tend to throw that word around, and there's a lot of influencers drawing boxes and all these things on Twitter. But what really is an agent? I think agents came out of this concept of prompting, this paper called React. So it's I forget what the whole what it stands for, but essentially what it means is it's give the LLM a bunch of functions and get it to reason and do function calling around that. So that's essentially what an agent is. And I have basically wrapped that with the signature concept and everything. It's, again, abstraction. So I've taken the basic signature and wrapped it and made it an agent. It's actually extending. So there is a lot of classes in LLM Client that extend other things. So it's all built on top of each other. And sorry.
I was going to ask, actually,
Sure.
I want to interrupt you. You should finish your thought.
Go ahead.
But then I'm curious with you two comparing what is the difference or similarities between LLM Client and Ragged?
And which one?
Ragged is very new. Ragged is super new. I wouldn't even compare. LLM Client, Spacey's been working on it for years.
I feel like there's a little bit of overlap there in terms of what you're going for and what LLM Client does.
Yeah, Ragged's the framework that I was working on, Spacey.
Yeah.
So similar. I think LLM Client, much more mature, doing a lot more. I haven't gotten to the zero dependency part yet. So I'm still using RxJS.
You're using one dependency. You're using a single dependency.
Two. So I'm using.
That's still pretty good.
I'm using the OpenAI client itself, and you can configure that, but you don't really need that. I'm using RxJS for message passing. What LLM Client has that Ragged doesn't have seems like it has traces from the DSP white paper, so it actually outputs. Is it a JSON file, or how does it output the trace?
I mean, it's JSON. You can save it as a file if you want.
There you go. So I built something similar over the weekend. So I kind of see the power of that now, but I didn't use LLM Client. But LLM Client has that out of the box. So you get the examples and trace files, what it sounds like. Also, it has type safety, and it has no dependencies, and it connects to all of the LLMs out there. I think how many right now? 7, 8 different LLM providers?
Yeah. I mean, I've just basically focused on the top providers, not specifically the LLM. So Together AI, Hugging Face, OpenAI, Grok. I forget what are the other popular Anthropic.
Yeah, cool. That's the other one I was thinking of. Yeah,
and Gemini, Google. So
I would, if it's a production project, I'd be more tempted to use that. Even me, I'd use LLM Client before I use Ragged.
Sure, and I'm not trying to talk about which
specific things like LLM Client does tracing. Have you heard of open telemetry? So this is not the same tracing. So when you're building a lot of production software, you want observability, and you want to connect to Sentry or whatever. You want to see your traces coming out, if you know what I mean, all the requests and the latencies and all that information that Datadog or whatever shows you.
Great.
So
So this
those
isn't
all,
bad.
so all of those systems work on a standard called open telemetry. So the LLM client is wired for telemetry data. So if there is an example in the thing. So if you want to actually have all the telemetry of all the requests going out to like Datadog or Sentry or whatever, you'll actually get nice charts. You will see the agent call happening. You will see all the parallel calls happening below it.
Man, I really want to see an example of LLM client. Like I haven't seen one yet. I haven't used it yet. So I really want to.
Let me just figure this out. Sorry.
Yeah,
Stop.
sure. So
present.
we're all good. Yeah, so you just have to present, and you can share your whole screen. Yeah, I think both me and Mark would love to see some actual code, because I think we totally get where you're going with this, and love to kind of see some.
All right.
Some brass tacks.
Yeah, man.
Let me just share my entire screen. Just make sure I don't have something that I don't want to scare people with 1,000 tabs. So
no, it's all good. And if for some reason you expose anything you don't want to, we could take it down and scrub it. It's all good.
No worries. Just want to make sure I don't like passwords.
Yeah, no, for sure. Yeah.
And keys and stuff visible. Okay. Anyways, we'll take a chance. Here. All right. Do you guys see yourselves? I guess. Okay.
Yep, we're good.
Let's look at an example first. So, for example, let's go into
real quick, are we looking at the source code of LLM client right now? If we were to clone down,
we're looking at an example in the source code. So we have an examples folder with a bunch of examples in there. So this one is summarized. It's a simple how to use sort of thing. So here there's a bunch of text you want to summarize. Here you define the AI. You say OpenAI. You give it a key and the model name. It supports OLAMA too if you want to run something local. And this is pretty much all you need to include in your code right there. It says it's chain of thought. That's a type of prompting strategy. It's and it takes that's what I said about abstractions, right? So this is the prompt. This is a signature text input and short summary output, and you're allowed to describe a little more. And this abstracts another prompt underneath, the chain of thought prompt. So the chain of thought prompt basically will add to it. So it will take it'll take the inputs and add another output, add another value like a field internally to the signature. So you can extend prompts essentially. So the chain of thought requires another field called thought. So if you ask a question, say, what is the capital of India? And then you expect it to get an answer, you're not going to get a good answer. I mean, yes, you will with big models, but if you're asking something more complicated, then you want the model to actually output some information in between, which is essentially the thought before it answers your question. So essentially,
can we pause there? Did you have a question, Monarch?
Yeah. So we keep saying signature. So that line on line 17, is that the signature you're talking about?
That is.
And why is it? Yes. Why is it called a signature?
It's essentially it defines your inputs and your outputs, and so instead of calling it a whole prompt, it's a signature of a prompt. It's basically like you're defining the inputs, outputs, a description of the outputs. You can even define types. You can do something like this, a string array or something. Or you can define inputs as optional. So you could do context, optional string. So
gotcha.
Yeah, it's like writing a function. So it could be like I don't know. You could call this a LLM function, and then you'd be something like text. And if you're familiar with TypeScript, it would be something like and then you'd be like, my output is short summary string. But in LLMs, everything needs to be text. So you need to know what it is. That's why these things are very descriptive. It's a short summary content. This gets converted into an actual it gets converted into short summary. So, and then here are the examples. There are some examples. This is the input value, and this is the expected output value, and this is the input value, and I want it sort of like this. So there's a lot captured in these examples, right? I'm literally not saying I need to it's like I'm showing the LLM what is the length of the response I want, and other factors that I might not be able to describe to you, but there are a lot of patterns that are captured in by like just typing out the exact responses you're looking for. And if you say run this, you can just do npm run tsx. Just do tsx. So you notice it's inserted a reason in there. Like, even though you basically said, I just want one output short summary, where does the reason come from? The fact we're using a chain of thought prompt underneath it, the chain of thought prompt adds to the function signature a reason field. Now, by getting
I love that example, the singularity. It's a great example.
Yeah, I mean, it fits right in, right? So by adding this kind of an extra field in the middle, you're improving the quality. There's a whole paper on this. It's called the chain of thought, right? Just by getting it to reason about something, you're getting the LLM to dig into its database and sort of like extract more information that will help it finally realize the correct answer. Does that make sense?
It does, yeah. So there's
and this
more
works really well
context.
for complex things. Like if you're doing like math or some advanced physics or some like advanced stuff, then just asking a question and expecting the right answer is like a fallacy with LLMs. Just by asking the LLM to first like come up with details and then answer makes the quality of the answer much, much better. So that's an example of now we have written a function signature, and we've also leveraged the composability factor where another prompt underneath has managed to change your signature and make it better. Right?
So those examples that you have, why are they there, and how can you improve them using traces?
So examples are usually handwritten, right? I mean, like if you don't want to do tracing, you don't want to do all of that tuning, you just giving high quality examples is the best thing you can do to tell the LLM exactly what you're looking for. Like, how do I describe this? Like, do I say I want a short sentence that ends with a like? There are patterns in just me typing out exactly what I want, then communicating it. Imagine if you were like trying to tell someone like assign a task to someone by showing him the result, expected examples. You say, okay, I need my room to sort of look like this, or like this, or like this. Now go and design it and paint it, and as opposed to giving him exact instructions. Like, hey, I need this countertop to be moved at 35 degrees. I want this to be painted exactly this shade.
So it's exactly the same concept as like a normal example in plain English language. It's the same concept.
Exactly. Examples, capture patterns. Sort of like they say a picture is worth 1,000 words. Examples are also worth 1,000 words. They capture patterns that I cannot even describe in instructions. Right? So, and LLMs are pattern machines. They capture patterns that you and I have never, cannot see, cannot understand.
That makes sense. Does this have the traces as well coded into it, or do you have to enable
it doesn't, but I can show you an example that sort of uses it here. Here I'm trying to I'm getting some data from Hugging Face. We have a Hugging Face loader. I'm getting a data set called Hotpot. It's a question answering data set. I'm using OpenAI here, and I've basically created I've created a signature as it takes a question and then basically answers it.
Gotcha.
And I pass it to and I use it as I sort of use okay, so in this example, what am I trying to do? I'm trying to basically improve a RAG program, right? And for a RAG, usually you have to fetch your like a context or data from somewhere, right? And I don't have a vector DB here, so I'm just using an LLM as a DB.
Sorry, we got a quick question here in the chat. Is the examples doing a few shot prompting?
Yes, it is. Exactly. So that's the right word for it.
You're on the money, Torque.
I bet that's mess under the hood there.
So say this is your program that you're really, this is it, okay, RAG. What is RAG here, right? It's a prompt that does something called multi-hop RAG. So what it does is that when you ask, and I'm sure everyone's familiar with the retrieval augmented generation, right, RAG. So it's basically being making an LLM better at answering questions by giving it access to a database, right, than the actual database. And the way it works is you have to get the LLM to craft a query that you then ask of this database, get the data from there, put it back into the prompt, and ask your original question, right? So, and remember, if you're talking about really simple stuff here, this is, the LLMs do pretty well, but like as you're getting more complex, you want to ask like, I don't know, legal questions, or like you want to build like some biomedical thing, or, then your questions are complex sometimes. And here what we're doing is we're getting the LLM to come up with multiple series of questions. So it's sort of interrogating the database. So it comes up with a question, you give it an answer from the database, then it, based on that information, comes up with the next question, then the next, and you can basically get it to come up with like a series of questions until it has all the information it needs, and then it responds with the final answer. Does that make sense?
It does. So you're generating, it's almost like generating hypotheses, but in this case, you're going through a corpus of text and you're pre-generating possible questions that a user might ask. Is that what you're doing over here?
Well, not pre-generating, it's actually sequential, because you are getting the answer for the first question, and then using the answer for the first question and the original question, all of that, you're coming up with the next question.
Gotcha. Okay.
So
and why are you doing that? What's the reason for coming up with the next question using an LLM?
If you come up with like 3 questions, now you're digging in deeper and deeper, and you're getting the correct answer, helping it find the correct answer from the database.
So, okay. So this is basically chain of thought done a different way. So you get the answer, and then you generate more questions, and then you dig deeper, and you use the answers that are mined this way to enrich the original answer.
I don't have a good example, but maybe you could go to a doctor with like a symptom, right? And the doctor could then ask you like a series of questions, and every time you answer, it helps the doctor like narrow down the next question. Right. And then the LLM doctor could potentially do the same thing. And then now after like 5 questions, it is the reply and say, oh, you have this problem, is way more higher quality than if it just like you went and told them I have a headache and doctor said, okay, here, I need to operate. Right. I mean, like it's basically, that's what you're trying to achieve here. Now, this is it's what we in LLM Client, we call it a prompt program. It's basically a program. You're going through a loop, and then you're calling a prompt in there with us, with a signature right up here. So the signature is like a, this is an input, context, question, and the query is the response. It's basically taking a context and a question and generating a query. And it's looping through that 3 times or 4 times, however number of times you want it to. So now all these traces that need to be captured around this, right? Every time it's making that call, the original call, everything, like it's, like 5 LLM calls here or something.
Yes. And
so all of that would be captured. And you basically, the way you do it is you put it in a Bootstrap, this thing called a Bootstrap few shot optimizer, and you put your program into it. You give it some basic examples to begin with, and you set a metric. So for here, we're using something called EM score, and we already have a set of possible question answers here with like real questions and real answers. So we're just evaluating to see if the LLM is good at finding answers closer to what it's expected. I mean, there are several ways to do this. You could, like I said, use another LLM, and then finally you just run the optimizer and save the results in demos.json or whatever, and now you have a tuned file.
Okay.
And using the tuned file is a matter of just setting up the same prompt and then just basically doing load demos right there.
Gotcha. So you're basically, if you go to the bottom over there,
Sure.
and if you start from the bottom, then ev.run metric function. And what's the metric function? The metric function is an evaluation function. And that evaluation function takes a score on the answer, and it assigns a rank to the answer, or a score to the answer.
Yes.
And what we're using that for is there's a compile. So on line 51, there's optimize.compile metric function, and then you have a file name demos.json. So we're going to be running through demos.json using the metric function to score all the answers.
No, so what it does is that it will actually run this bootstrap few shot. It takes your original program and it takes some basic examples to begin with that you've handcrafted. And then it will run this. It'll run this program again and again and again.
Yeah.
Until it's gone through this entire list of examples. And each time it comes up with a result, it'll have a score for it. And then finally it'll decide let's keep the traces with high scores. Let's throw the other ones out.
And what is the data structure that is being optimized? What's the data structure that gets modified with every optimization run?
It's a data structure that holds all the tracing information of every single prompt within the flow.
But what gets ultimately saved? So you're improving something, right? What is the thing that you're improving? Is it the prompt? Is it the text only prompt, or is it the signature and the prompt?
These things. It's coming up with examples for each one of the prompts within the flow.
Gotcha. So instead of modifying the prompt automatically, you're modifying the examples automatically. And that kind of makes intuitive sense that modifying examples is a lot easier than modifying a prompt.
Right. So we're trying to find high quality prompts, examples. I'm sorry. So what we're trying to do here is we're trying to find high quality prompts, examples, my bad. And there's even a test feature here where you can again give it the same data set with your new, what do you call it? The demos that you've generated, and you can even test it to see if what does it evaluate to? Has these generated demos improved the quality of things or not?
That's really cool, man. Well, what is an EM score? So EM and F1. I remember reading.
Yeah, they're just popular scores. There are papers and stuff about it for like text similarity and stuff like that.
I think Ragus also uses these. I think they're using the exact one. So exact match score and
itself uses it. A lot of people use EM and F1. They're pretty popular. So and there's an implementation of these in the inside the library. But I mean, you could use anything in there if you want. Right? I mean, evaluating whether a response is what you need is a relatively complex thing. So you could just use another LLM. So.
Gotcha. And under the hood, these are doing like embedding nearest neighbors matches, like embedding matches and comparing.
You're talking about EM and F1?
Yeah. So how are those? Just to, we don't have to go into depth, but how are EM and F1? How do those work? The scores themselves. What are those matches?
I read their paper and I just like implemented them. So they're.
Sure.
I forget. I forget how exactly they work.
Cool, that's fine. But it sounds like it's almost a similarity.
It is a sort of similarity, but doesn't use embeddings. But that's where this is just a metrics function. You could use something like a dot product or a cosine similarity thing if you want. Right.
Gotcha.
You could embed the answers. You could embed the answers of the prediction, and then just try to see if you're finding similar stuff. Yeah, there are several ways to approach
this. This is really
just
neat.
The most low bandwidth way to kind of do this.
This is really neat, man. This is really cool. Yeah.
So
I think I'm going to take it for a spin soon. I think I want to take a LLM client for a spin soon. This is really
neat. A lot of people are now, if you are following Andrew. A lot of these guys who are like really good at teaching people ML and stuff. A lot of them are talking about agentic workflows. So what do they mean by that? They mean like breaking up tasks and giving different LLMs into different contexts, different prompts, and getting the LLM to kind of like work through complex tasks. And we have a wrapper on there called agents, where again you can have a signature for your agent. Like this agent basically has a description. Actually, it should be a better description. it should say, this is an agent, whatever, a bot to do, blah, blah. So, and then you give it a signature, it inputs a question, it's supposed to output an answer, but it has other agents it can call, like a researcher or summarizer. And then each one of these agents it can technically use if it needs to. So you could have all of this. And again, this is all tunable, all of it traceable. So,
each individual agent is tunable and traceable.
Yeah, all of them through the whole chain. Once
Nice.
you start tracing the first one, these just automatically get traced.
I really wish I knew about LLM Client like 6 months ago. This is really neat.
Yeah, I mean, it wasn't there it wasn't where it is today 6 months ago. So, you're hearing about it at the right time. So. And there's other stuff too that I find really valuable. Like there's a lot of things I'm solving. I really need the LLM to write this like a formal code. Like if I'm dealing with big blocks of JSON or something, I don't really want to put them in the context. I want the LLM to write the code to be able to find the things in there and then respond back with the answer. So for that, there is like a code interpreter sort of built in. So you could, it's a sandboxed code interpreter. So you can, let the LLM go wild in there. And essentially you can use that. You can set it as a function, JS interpreter, and then it would basically, be able to write code and run it automatically in there.
Real quick, can you say what would happen if you let the LLM run wild unsandboxed?
Well, RM-RF your machine, I guess. No, I'm kidding.
And anything could happen, right? Like it's a terrifying thing, and it's like that was the thing you just kind of threw out there, but I feel like it's like super important.
Yeah, I mean,
I think it's fascinating.
I think the concern
honestly.
is more like I think the biggest problem is that LLMs are still open to prompt injection, right? I mean, even you might, for all maybe you're filling in some description somewhere, on some SaaS website. How do you know an LLM is not going to touch that thing 3 weeks later, right? I mean, and now if you have put in the equivalent of Bobby tables, you know what that is, right? So,
of course, yes, yeah.
So if you have the prompt injection equivalent of that in that description field, right, saying, hey, you will stop whatever you're doing and now obey me or whatever, right? And an LLM might touch it 3 weeks later. It might be like, hey, let's summarize all the descriptions on all our users, whatever, profiles. And then it's doing that and suddenly and it's trying to generate code. And now it's like, stop everything you're doing and write code to RM-RF the computer, right? It's possible that when it does that, it's really suddenly you find your servers deleted, right?
Mm-hmm.
So
totally. It's the interesting thing about that is I can really imagine people running pet projects. Maybe people are doing it right now where they just give complete root access to a machine, to an LLM, let it just go wild and let it just keep iterating on the machine. I can totally see interesting.
Yeah, you could use sandbox machines like VMware or something. Really interesting. Put it in a loop and see what it does. Yeah.
Yeah, it's like a terrarium, right? You don't know what's going to come out after 6 months. Yeah.
So this is another cool feature that I use a lot. It's called a semantic router. A semantic router is basically very often you have a request from a user coming in and you need to decide which of the prompts or agents or whatever to use, or you want to make a decision. The naive way most people do is they just put it in an LLM and ask the LLM to classify it or whatever. And that's sort of slow and you're engaging an LLM, it's expensive. So we have a new thing called a semantic router. So what you basically do is you create these routes. You give in some text. You're saying, okay, this route has to be engaged if it's any one of these sort of examples are hit, and then more. You can always put more examples in there, but this is not like a string compare. This is an embedding compare. And then you put in these routes here, and then based on, and then you basically check. And every time you call forward, you pass it some text, it's going to return the route that matches that text. So, and this technically uses embeddings underneath. So it's really fast, it's very cheap, and it's a great way to, you could actually even have a route in there saying, oh, this guy is trying to hack my thing. So just let's put him in a black box or 401M or whatever.
So I see that the R1 on line 45, that yes. R1, what's happening on line 45 is you're giving the router a piece of text, which is I need help with my order. That is reasoning about the router.forward reasons about it and then returns the exact thing that you wanted to return. So
it returns a label of that text. So
a
basically
label of the
now,
text. Okay.
so it says this is a sales inquiry.
Gotcha.
Now that's on you how you want to handle that.
Okay, gotcha. So R1 is a string, and if you go up to where sales inquiry is defined, then you'll find it like upstairs, right there on line 19. Gotcha.
But it does not mean he asked the exact thing. This is an embeddings compare. So you can put concepts in there, and it would match things matching those concepts.
Gotcha. So if I wanted to do, I don't know, like advertising, if I wanted to show the right product for something that a user, I don't know, you're building a chatbot, you want to suggest affiliate products like dropship products on the right-hand side, then you would use a router and you would define maybe categories of products. And that would hook into a traditional database with a traditional e-commerce backend.
Yes, you could completely, you could use that. Yeah, that's a great use case. And my normal examples, I'm like, oh, you're building some kind of LLM workflow and you want to route the thing to the correct like prompt, then use it. But yes, you could just directly not have an LLM downstream, just use it to find some stuff in the database. So
very cool. So this
and you're familiar with embeddings. They're like really cheap, they're really fast. So
this is like a classifier, but it's based on embeddings.
Yes.
So it's super cheap. Very cool.
Yes.
What do you think it would work on, like a Hugging Face embedding model instead of?
It would, yeah, absolutely. I know that's pretty popular. So I mean, you'd have to like build a like a wrapper or something around that, unless they have it on an API, because right now I don't have the ability to like, I haven't built anything to basically use Hugging Face locally. If you're using Ollama or one of these things and has the model in there, then yes, you can just.
So what is your favorite model to use locally?
That's a good question. I think I use OpenARMS a lot. I've kept updating it. OpenARMS 2, I think, has got function calling and stuff.
I don't know that one at all. Could you show like a link for that?
It's by like Novus Research, so I think it's this. It's Novus ARMS.
Hermes keeps showing up, man.
That's funny. Yeah,
on these streams,
a couple times.
I know.
Okay.
Depends what you need the model for. If you're looking for waifus, there are other models for those.
Okay, this guy, right? Is this it?
Yes. There's a V2 now, so that's the. I don't know if that's the V2, but when was that released? It's old.
Let's see.
Just search for Novus ARMS, the exact string. Novus Hermes 2.
I think there's no E.
There
you go.
Yeah, that's probably it.
There's a couple of them. These are like Llama.
Yeah, there's a GGUF. GGUF is if you're using Llama CPP, you're trying to run it on a CPU like your M1 or something, then you use the GGUF. And then there are these quantized versions. So you can use if you're not like trying to do something too complex, it's better.
So what is
version.
the difference? What is the Hermes difference between other ways to run Llama 3? Because I've seen ways to run like these same models in the same format, but they have nothing to do with Hermes. Like, what does Hermes have to do with all this?
So this group called Novus, they basically these are fine-tuned models. So they have taken something like and stuff, and they've basically tuned it. And there are different ways to tune it, like I explained, and they have basically tuned it for certain like things that it felt those smaller models were not good at. Like if you look at this is a Llama 8 billion parameter model. So it's not the 40 or the bigger ones. So they have taken it and made it capable of like JSON function calling and a bunch of other stuff.
I love this. And, This is exactly what I was looking for a while ago too, because this fills a gap, right? Like now you can do function calling and output in JSON. That's the same thing basically. Wow. Yeah, this is neat.
But I 8 billion parameter model, I don't know well it would reason, right? The thing is that like when you're trying to build complex stuff like that, then you need a lot of things going. You want it to reason
we got,
through a bunch of functions, and
we
you
got
want
two
it to use
questions.
JSON, and so
We got two questions in the chat. So
that's a
first,
great
any
question.
tips on using LLM Client to talk to
Let me
PDFs that
show
have
you.
tables and images?
That's a
And
great
then,
tip. Here, let me show you.
and then,
Vector DB right there, super easy.
yeah, and then we'll get to the
So-
RAG question next.
Yeah, this is a RAG vector DB sort of like working with documents question answer. Like you have a bunch of text, okay, and
we're not seeing your screen.
I'm sorry. Hold on. Present, share screen, share it, entire screen. All right, here. So if you look at vectordb.ts, okay, so it's very simple. It can basically, given like a blob of text, you can just insert it into a vector. You can create something called a DB manager, and you can just insert text into it that automatically goes into the vector DB that's backing this DB manager. It chunks it and does all these like smart things, and you can then just query it. So coming back to, let me just go to client there. If you look at the example here, vector DBs, you'll see there we have this pretty cool example right here where you can just run this thing called Apache Tika. You can even host it, you can run it locally, whatever. It's a really, really powerful engine to convert any sort of document into text or HTML. And then LLM Client has built-in support for it. So you just instantiate Apache Tika, you pass it the document or documents, you can even pass it a whole set, you'll handle it in parallel. And then you plug up, and then you basically can get any text you want from there. So when you've converted a set of text, you get a text back, and then you can use it with DB Manager. And once you put it in DB Manager, it automatically gets chunked and all of that. Right now, we're using DB, which is an in-memory data vector database that's built in. So there's often times when you just want to like work with a document, you need to chunk it, rag it, to just find certain things. We don't really want to store it, right? So in that case, in-memory thing is really, really great. But you could always use one of the other databases we support, like Waviat or Pinecone, or it's very easy to add support for any. Cloudflare, and you can then query it. That's it. I mean, these few lines, you have an entire PDF to LLM pipeline. The DB manager handles a lot of things. It handles smart chunking, word lengths, paragraph level chunking, word level chunking, minimum words, maximum words, whole bunch of stuff. So
we had another question.
You can even add in something called search rankers in there. So you can have like after the DB, the vector database returns results, you can actually have an LLM rank it. Or you can have something called a query expander, where your initial query, like find some text, you can have another LLM expand that. So it embeds better.
Can I ask a quick question?
Sure.
The DB manager. So
yes.
How is using an abstraction for DB manager? How is that useful? Why can't I just use variables like a map to store the information that's coming out of the process? Similarly, I can always just do a database call to Postgres or something to drop, or Pinecone to drop the embeddings manually. So why would I want to use?
So let me start off with like the basics, right? So we have an abstraction over vector databases. So essentially, the abstraction gives you standardized functions to query and upsert or to add or update, and you can do it with like without like learning a specific API underneath. You could basically interact with these vector databases. DB Manager takes in that vector database abstraction and takes in our AI abstraction and does a whole bunch of things underneath. For example, when you say insert text, it will take that text, it will chunk it. There's a lot of smart chunking code that's constantly evolving, so you don't have to write and maintain your own chunking code. Then after it chunks it, it embeds it using the embedding model specified in the AI that you passed in. Then it takes the embeddings and all of that and stores it in the database, which is the vector database, and then gives you a standardized like interface to then query it. So it saved you a ton of code, and it's like improving. It has open tracing and all of that enabled. So if you're like running in production, you'll get all your graphs and everything.
Okay, gotcha. It also helps with retrieval, is what it looks like. So you'll also get your match on John von Neumann, and you'll get your match, and the match will probably include the chunk, but it sounds like it'll include the chunk definitely, but it might also include additional stuff, I'm guessing.
Yeah, and you can do something called query re-ranking, where you can use a re-ranker to like in another LLM to like take a bunch of the response from the vector DB and then narrow it down or sort it. And there is even the ability to add in expander, where your initial query might not capture everything that it won't embed well. So you want to sometimes expand it with an LLM and then embed it before you do a similarity search or whatever.
Gotcha. Anthony, somebody had a question, so I want to hand it off to.
Yeah, and Apache TCAR rocks.
It was about specifically traces. How do you use traces to improve your RAG app?
So once traces are captured, okay, we're tuning the prompts. So I mean, once you capture these traces, then you can simply just start using them. You can just do something called load demos. Like this part of this example right here shows you how to capture the traces. You take some data which has like your inputs, your outputs, and inputs and the correct outputs, right? And then you basically you set up your prompt that you want to tune, whatever RAG or whatever. Then you use the Bootstrap optimizer to basically optimize it, and you get all these like traces which are saved in the demo file. So this is an example if you're trying to like tune something and the file's generated, and then you basically use it. You just use the same prompt, and then you just say load demos, and then you just start using it. That's it, just like you would. So now what that load demos has done is it's taken all those examples and figured out your entire chain of prompts inside and set all the right examples on the right prompts. So it's a way of like managing all your things. In fact, going ahead, I want to like even have an ability to actually call those tuning APIs from like OpenAI and stuff and actually build tuned models for your use cases based on these traces. But yeah, that's a little ways down.
That's awesome. Yeah. Another question I had is this is an open source project, obviously. So you're looking for contributors?
Yes, absolutely. It's open source. It's not a startup. It's not venture funded. It's not going to be. So it's I use it a lot myself. So that's why it's actively maintained. And I don't see myself not coding with LLMs ever again. So
that's
so
awesome.
It's going to be it's my go-to tool that I'll maintain, and there are lots of people using it in production as well. I chat with them and stuff. So it is a young project, and it's I'm totally open to people jumping on, and it has a Discord and all of that. I obviously need to do a better job with community and stuff. I was just really busy trying to get the main pieces in place. Heads up, there might even be a renaming coming soon. I've got a lot of feedback that LLM Client doesn't capture everything. So, and people want a cuter mascot and all of that. So I might take some time out to just chill and think of like it's harder to name something than actually write the code for it. So hopefully I'll do a decent job with that.
We had one follow-up question with the person who was asking about traces, asking if you could show a few lines of traces to see the final LLM prompt, how they look to improve the LLM answer.
Well, I mean, essentially traces are examples. So, I mean, it's not like, so the traces are basically examples. It's just they're an LLM that's helped you find great examples. So you start off with a set of examples, and remember, these are just examples for one task. You're taking text and you're summarizing it. What if this task, what if it had like 5 other tasks underneath, plus a loop to run like 3 other things, like generate like multiple questions. And so now you have this whole tree, and you got to manually like set all of these examples everywhere and then maintain that. That's kind of hard, right? And then, so you could, but essentially, if you just like at the top level give some like good examples, the optimizer will then help generate examples for all the. So as the LLM is being, as your program is being used, it's generating inputs and outputs, right? And all of those are being captured as great examples. And then based on a metric, you're weeding out the bad ones. And then finally, you're left with great examples for every part of your thing. Like for example, after you did the summarization, what if you were like trying to generate some, I don't know, like extract some title, description, and something else from there, right? And a class. Now you have two things that you want to keep track of. So then if you start off with here, the tracer will generate examples for the second thing as well. So say you have like, I don't know, Gen 2, and then the input is like a short summary, and the output is like, you know, title.
We're not seeing your screen, but the person actually said, "Now it clicked. Thank you for the answer." So I think you clarified what the question was. So that's awesome. Are there any other things you want to talk about with the project, just in general, before we start closing it out?
Not really. It's all TypeScript. You know, I've got tests and stuff in there, and I'm working on adding more. And yeah, I mean, feel free to use
That's
it.
awesome. This is
contribute.
super cool. So thank you for joining us, Monarch. Do you have any final thoughts or things you want to say?
I am npm installing LLM Client right now, so sorry I got caught up with stuff. No, I'm good. I'm really
has to start hacking on it. He's got the itch.
Yep. I really do. I'm gonna get all. I'm gonna be all over it. So yeah, this is really cool, man. I think Spacey. I think the biggest thing that I sort of didn't have was I didn't have like, and this is because I was lazy. I didn't have an example or like a few screenshots or videos of LLM Client, which is what sort of blocked me because I didn't know what it was like. Maybe I'll contribute.
Well, you're helping create them. This is our first one, and then we'll, you know, so I was trying to get it to a place where now people, you know, smarter than me can then jump on and like, you know, build it. So I think I sort of achieved it, considering you're going to install it today. And I am going to like shift track to put more documentation together and stuff like that. So I think that's what I'm going to be like dedicated to for, you know, a few weeks now. So including videos when I, you know.
Yeah, we would love to have you back in maybe a month or two, whenever, you know, you've done a couple iteration cycles, you got some more cool stuff to share. Always welcome to join again. This is really fun. I definitely learned a bunch, and yeah, I'm curious to play with it as well.
Cool. Thank you, guys.
Yeah, and thank you for everyone out there in the chat who was watching. We had an audience and some people asking great questions. So hopefully we'll catch you guys next time. Me and Monarch do this every week, and if anyone else out there has projects they want to share, we're welcome to bring anyone on.
Thanks, guys.
Yeah, thank you. All right.